excited to be here today. I'm local, actually, and I've been monitoring this conference for years, so I'm excited to finally be here to share what I know about Kafka and hopefully get you excited about this technology. So I'm going to wake you up. I know it's the end of the day, but I am very loud and I'm very enthusiastic about Houseplants and Kafka. So yeah, I work for Confluent. We do a lot of Kafka. We do a lot of real-time data streaming. And so I just love to talk about those things. But I'm a well-rounded human. I do things outside of tech, and the only other thing I do is houseplants. Case in point, here are some of my houseplants that I own. I have about 40 or 50 of them strewn about my house. How many of you have houseplants? I feel like, yeah, most of you, you're here this late in the day, you came for the houseplants, not for the Kafka. I get it, that's fine. So this is gonna resonate with you, right? Houseplants, sometimes we just make it look easy, you know? But sometimes they're difficult. I got a lot of my houseplants over the pandemic, and I had 24/7 to take care of them, and that was wonderful. You know, you could check on them 45 times a day and do what you needed to do with them. But I live my life now. Sometimes I go to Oakland instead of hanging out in the peninsula. And so occasionally I have houseplants that turn out like this. They're not supposed to look like that, right? That's a sad, sad houseplant. And so I want to keep living my life. I want to live my best life here. And so I asked myself if there's a better way, right? I need to take care of my houseplants. I need a better way to monitor them that doesn't involve me going around and checking on them multiple times per day, right? And I know what you're thinking. Of course there's a better way. Amazon sells 45,000 different ways to monitor your houseplants, and they can be delivered same day, right? But that wouldn't make a good story. You're here to hear about Kafka and something more interesting than that, right? Many of you are engineers. You are a curious person, maybe even a creative person. You showed up at this talk. And so that's the wrong question. This is probably more accurate, right? Before I became a developer advocate, I spent a number of years building out streaming data pipelines with Kafka Streams. And so when I became a developer advocate, I promised myself that I was going to build interesting things that solve problems that I had, because then it's more fun to talk about it. And it's a win-win, because I get something cool out of it too. And so this was also an opportunity for me to build out an IoT project, get a Raspberry Pi, and play around with it. So this is the perfect storm. I could solve a problem that I had with my houseplants. I could use Apache Kafka at home. Who does that? We're gonna do it. And then I could also build out a project with a Raspberry Pi. This is great. So let's get into it. Let's talk design. What does this look like? So I figured there's a lot of ways that you can monitor houseplants, a lot of different metrics that you can look at, determine how you need to care for them. But the biggest one for me is, okay, what's their moisture level, right? Do they need to be watered right now? I don't want droopy, sad plants, okay? And so I would get some soil moisture sensors, put those in those plants, connect that to the Raspberry Pi, capture those readings, throw it into Kafka. We'll deal with it later, throw it into Kafka. That's probably not good enough though. We need a little more information to actually make sense of those readings. So I'm gonna call that metadata for now. We gotta get that and throw that into Kafka too. Both of those data sets, we can then do some stream processing with those, combine those, and at the end, I am a lazy person. I'm not going to say lazy. I like convenience. And so I want to receive an alert at the end on my phone telling me when I need to take care of my plants. Great. So before we get into that, though, how many of you have worked with Kafka before? Okay. Some of you didn't raise your hand, and we can talk later, too. But for those of you who did not raise your hands, I just want to level set on what this is at a high level so we all understand. So Kafka is a distributed event streaming platform. If I had more time, I would go into the nitty-gritty details of this definition more. But basically what you need to know is Kafka is a Swiss Army knife of sorts. It's a unified, high-throughput, low-latency platform for handling your real-time data and allowing you then to build reactive applications that can then tap into that information in real time, all right? It's pretty cool. So we're going to use this as the backbone of this system to store this data and then allow us to do some stream processing on top of that real-time information. Okay, so going back to me and my cool project. So what do we need to do to actually make this come together? Well, first things first, we need some Kafka. All right, so Kafka is a distributed system. We need some sort of cluster with multiple nodes. Sounds like an infrastructure nightmare. I don't like managing Kafka, and here's my shameless plug. I work for Confluent, and we offer Kafka fully managed in the cloud. Beyond that, there's some cool things that we have built on top of that. Tools for integrating with external data sources and syncs with Kafka Connect, stream processing built into our platform with ksqlDB, and also schema management. So we're going to get into all of these eventually. I'm going to use this just because I'm going to spend a lot of time in this project managing some actual hardware. I don't also want to manage some infrastructure. So if you want to follow along at home as an exercise to the reader, if you want to build this yourself, just know that you have to have a Kafka cluster running somewhere. I don't care where you get it. Cool. So we've got a Kafka cluster, did some hand waving there. Let's go and dive into the physical system. I had the most fun with this. It was my first hardware project, and I decided to cut and crimp all of my own wires. It was really, really fun. This is not a hardware talk, though. This is not a hardware conference, but if you do want to follow along and build something, here are, the high level, the things that you would need to make this system yourself. I do want to go into the soil moisture sensors that I chose, though, because they're going to come up later. They caused me a lot of headaches. So these are I2C capacitive moisture sensors. They're about $1 each, so pretty cheap. I could have spent more money on them. Maybe I would have gotten a better sensor. But the cool thing about these, so they're I2C. If you don't work with any sort of IoT stuff or hardware components, I2C components communicate using a unique address, which is set at the component level, at the sensor level. And so all these sensors are wired together to the breadboard, and there's a single set of wires that communicate from the breadboard into the Raspberry Pi. And so that unique address is really important, so you know which sensor you're pulling that information from, right? Unfortunately, the sensors that I chose had a fun limitation that I found out after buying like 15 of them, in that the I2C address could only be set to one of 4 values. Cool. So for my 40 or 50 plants, I can only hook up 4 plants at a time with this system. Yes, there are ways around this. It's also beyond the scope of me and my skills for my first hardware project. But this is going to come up. We are going to come up with a way to get around this later on in the system. But just keep that in mind. It's a fun thing to consider if you're building something for yourself. So here's, again, a little bit more hand-waving. I built the system, hooked up the sensors, and I'm ready to collect data from these plants. All I had to do now was get that data into Kafka. That's it. Just put the data in Kafka. But before we get ahead of ourselves, anytime I build any sort of project, I'm kind of a nerd. I like to sit down and actually write a schema. It's a best practice that I just have drilled into my head, and it's a good best practice to adhere to, okay? It's going to save a lot of headaches. You can actually reason about the information that you're working with and make better decisions, hopefully. So I defined an Avro schema for these readings that I'm collecting from the moisture sensors. Pretty simple schema. We have the percentage moisture. That's really important. I also got temperature for free with those sensors, so I tossed that in there as well. And then I added a plant ID field that I was going to just manually assign to these plants. And I'm going to use that as the key of this information as we put it into the Kafka topics. All right, so this is how the data should look, but how do we get it in there? Well, there's a couple different ways to get information into Kafka, either the Producer API or Kafka Connect. Producer API, this is your low-level, sort of vanilla way of getting information into Kafka. It's great because it's available in all of your favorite languages and some of your least favorite, so, you have options. You'll want to use the Producer API if you either own or have access to the system or the application that's generating your data. So if I wanted to capture, specific log events on the back end of some website, I'll just toss in a producer there and just throw it into Kafka. That'd be pretty easy. The other option is Kafka Connect. As the name implies, Kafka Connect is a way to connect Kafka with external sources and also syncs later on. What's really great about it is that it's no code. It's configuration driven. There are dozens, hundreds of pre-made connectors out there for different sources and syncs that you can utilize. And so you write up a config for it, point to the data source or sync, how to authenticate with it, if it's a database, which tables or what query you want to execute against that database. And when you start running that connector, it's going to start pulling that information into Kafka, eventifying it, if you will. I'm still working on that term. Not sure if anyone wants to use it, but it's there. And just making that data at rest a little more real time, right? So what did I use in my case? Well, I own the Raspberry Pi. I am my only stakeholder, and I'm writing the script. So we're going to use the producer API here. So I'm going to use the Confluent Kafka Python library for my producers. You'll recall that tiny little issue with the 4 sensors that I could have hooked up at a time. I need to reference each of these moisture sensors by their address. So I'm going to hard code, red flag, I'm going to hard code a mapping of the sensor address to the plant ID that sensor is currently in. All right? We're going to come back to that because I should not be doing that. And then within the script, we are looping every 30 seconds over that mapping of address and plant ID. We are fetching that information, the moisture, computing the percent moisture, grabbing the temperature as well, and packaging it according to that schema we defined. And we're just going to produce it into Kafka. Cool. Pretty easy. So those readings are in Kafka. That's wonderful. That's half the battle. But that information isn't good enough on its own, right? Now I have a bunch of data that just says, OK, what are these moisture readings? But every plant is different. Every plant has different moisture requirements. And so I need a little bit more information to actually accurately make sense of these readings. OK? So we're going to use another data set, some metadata. Okay? And so I created another Avro schema. Again, this one's a little more interesting. Got a couple more fields in here because I couldn't stop myself. We've got a lot of the scientific name, the common name of the plant, the given name of the plant, because all of my plants have names, the low and high moisture threshold that plant is comfortable within, the same for the temperature values as well. And of course, I had to include the plant ID in there so that we can join it onto the other data set later on. So we have that schema. We know how it should look. What should we use to get it into Kafka? Well, Producer API, Kafka Connect. Which one? So Kafka Connect, it's really, really great for slow changing data at rest that is in a database or at the other end of an API call. Metadata or reference data sets like we're dealing with here, that's probably something that should live in a database, right? But I only have 4 plants that I need to deal with right now. And at most, I'm only going to have 40 or 50 rows in this database. So I don't know. It seems like overkill from an infrastructure standpoint for me to waste time putting this data in maintaining another database. So let's store the data in Kafka. That is a completely reasonable thing to do. You got to be a little smart about it and how you configure your topics so it's persisted for as long as you need it. But you can do that. Okay? So I'm going to store this data in Kafka. So I'm not going to use Kafka Connect, I'm going to use the Producer API. But another requirement that I had at this point was that I wanted this process of adding this metadata, updating this metadata, to be as lightweight and simple as possible from a user standpoint. And I am the only user, so okay, we're gonna do what I want. So to make it even easier to add this data and update this data and get it into Kafka, I don't want to touch my computer, right? So let's get some help from Telegram. So at the end of this, I want to receive alerts on my phone, and I'm going to receive that on my phone through an app called Telegram. Since I'm going to be getting data from Telegram, I figured, why don't we just use Telegram to write the data to Kafka also? So if you're not familiar with Telegram, it is a messaging app like WeChat, WhatsApp, but the cool thing about it is that it offers a really convenient messaging API around it, and the ability for users to create bots. Okay? So you can create a bot, you get an API key with which you can authenticate that bot and write scripts for how people interact with that bot, what that bot responds with, and what it does in response with it. So they have a really cool Python Telegram bot library that you can use, again, to write the script to deal with that. And so I could write a script to process any incoming messages, which then could produce data to Kafka. Pretty cool. So for any Telegram bot, you're going to follow pretty much the same structure. You're going to define a high-level conversation flow that lays out what are the stages of this conversation, what is it going to do in response to any messages it gets, the different conversations it can go through. And basically, you're just creating a finite state machine of like what it's doing in response to the different stages of this conversation. And there's a message handler, a function that then at each stage can handle the incoming messages. So going into one of these functions, these message handlers, so at this point, the bot has already prompted for the low moisture threshold. I, as someone communicating with the bot, has given it a low moisture threshold. The bot is extracting that from the user input, storing it temporarily in a mapping in its state, and then it's going to pass that on to the next stage in the conversation, and I'm going to give it the high moisture threshold at that point. So we're going to do this for every stage of the conversation, and I'm going to collect all of the data that I need according to that schema. Okay? And once I've collected all of that data according to my handy-dandy schema, I can then write it to Kafka. And at this point, we can follow the same process that we saw earlier. I'm going to create a basic Kafka producer. It's going to know how to serialize this particular object according to that schema that we have, and it's just going to package it. I have some helper functions in there to translate between that dictionary to the houseplant sort of object, and we produce it into Kafka. Pretty standard. So this is what it looks like on my phone. So it has, some commands that I can give this bot. So I want to update this plant, and then I follow through with all the information that it requests. We confirm it, and it's going to produce it to Kafka for me. So this is pretty great. I don't have to log into my computer to get this data into Kafka. It's just right from my phone. And so if I want to add some plants or tweak a couple of the low moisture thresholds, I can do that pretty easily from my phone. But that's not good enough, is it? I can add metadata, I can update metadata, great. But what good is adding new metadata if I need to go back into the Raspberry Pi script and manually update that awful hard-coded mapping of sensor ID to plant ID, right? I still have to go do that. So rather than have that be hard-coded in the collection script, I figured, okay, I can make this a little more event-driven, and I could get that data from Kafka, right? And so I need to get that sensor mapping into Kafka, all right? So we're going to collect a little more data here, again with Telegram. So this is a pretty simple schema as well, just a mapping from the sensor ID to the plant ID. And we're going to use the sensor ID also as the key of these messages. And we're going to follow the same process. It's a much simpler conversation handler because there's only 2 pieces of information to collect. And here, it's going to prompt me for which sensor ID I want to update. And this can be hard-coded. This is never going to change. And so it's going to present that finite list to me up front, and I can put in the new plant ID that I want to assign that sensor to. And cool, so that is in Kafka now, and I just have to change my Raspberry Pi script to to be more event-driven, to get those mappings from Kafka. And so we need to get the data out of Kafka. Similar to producing data, the considerations that you're going to go through when you figure out how you're getting data out of Kafka, there's a lot of similarities, right? You're either going to use the consumer API or Kafka Connect. The consumer API, like the producer API, it's flexible, available in a lot of different languages. You're free to do whatever you want with the events at that point. If you're looking to move data somewhere to maybe a database or some longer-term data store, then Kafka Connect is going to be a little more useful in that regard. But here, we're going to use the consumer API. That made sense. So I'm going to add a consumer to the beginning of that script. So before it starts to collect any data from the sensors, it's going to block. It's going to build up a full mapping with the consumer of 4 sensor IDs to plant IDs. So we know that every sensor has a plant that it's mapped to. And then it's going to go through that process of looping every 30 seconds. And at the end of that loop, it will try to pull for new updates, new mappings. Okay? But there's a couple things to keep in mind here. So if that application, that script were to crash, right? And we bring it back up, which happens, and that's fine. That consumer is going to pick back up where it left off, because in Kafka, the consumers, by default, are going to commit their offsets. They're going to keep track of what message they've last seen and where they've last processed, all right? I don't want that, though, right? Because if I only have 4 mappings in that topic, and we crash and we come back up, well, I've already seen those 4 mappings. I'm not going to get them again. Right? So I want to turn off that functionality. So in this case, I'm going to use something called a non-committing consumer. So to actually enable that, you're going to use 2 configurations. First, you're going to set enable auto commit to false. So we're no longer going to store those offsets. And then in the event that it starts up and there's no offset, where does it start? And you set that with auto offset reset, so we're setting it to earliest. So when the consumer starts up, it doesn't have an offset with which to start at, and it's going to start at the beginning of the topic, the earliest spot in the topic. And it's going to start basically afresh, build up that four entry mapping, and we can hit the ground running. Cool. So at this case, when I update a mapping, within 30 seconds, we're going to see that populated, which is enough time for me to move the sensor from plant to plant and rearrange some things. So cool, this does what I need it to do. That's great. So now we just have to actually process the data, make sense of it, right? So to do some stream processing within the Kafka ecosystem, you have options, isn't that nice? You can use the consumer and producer APIs, sort of the OG way to do it. This is great, again, available in whatever languages you want it to be available in. But to use it for stream processing, it's complicated, okay? Especially for stateful stream processing, because you're gonna consume from Kafka, do your processing, your transformations in memory, and then produce it back to Kafka. But okay, what if that instance goes down? What are you doing with your state? Where are you keeping it? I don't know if you have an answer to that, okay? Because it's just an annoying thing to think about. For stateless processing, absolutely. Use the consumer and producer API. That makes sense. But for something stateful like this, you should probably use one of the next two things. So moving up in the sanity and ease of use is Kafka Streams. So this is a Java and Scala library purpose-built for stream processing, for stateful stream processing. It is really good at it. It takes the hassle of managing state off your hands and gives you some cool a DSL to play around with. So the cool thing about this is that it's built on top of the consumer and producer API, so you get a lot of the cool things that you get from consumers, like scalability and the fault tolerance, the high availability of these instances. And so you can spin up multiple instances of a Kafka Streams application, and it's going to parallelize the processing, share the input load, and process in parallel, which is pretty great. And if it's a stateful pipeline, it's going to commit that state back to Kafka, so that if an instance goes down and we redistribute that processing to another instance, it can get that state from Kafka pretty easily, all right? So you never lose that state that you need. And so to make it even easier, we have ksqlDB, which is a SQL wrapper on top of Kafka Streams. And this is what I'm going to use for this project, just because it's also built into the Conflict Cloud console, so it's pretty easy for me to manage. So how do we actually process with ksqlDB? First things first, get the data into it. And you also have to decide how you're representing the data. So there's two main constructs. We have tables, we have streams. Streams represent ongoing series of events. Tables, on the other hand, are going to represent the latest value for a given key. So let's look at that metadata first. This should feel very familiar. It's just a create table statement. We want to represent the Houseplant metadata as a table. And so the most important thing is, where are we getting this data from? Houseplant metadata is the topic where that data is currently residing. And the value format is Avro. We spent time creating that Avro schema, and it's going to pay off here. Because ksqlDB as a consumer is going to look at that topic, find out, see that it has an Avro value format, look up that schema in the schema registry, and use that to parse all of the fields and the types for this data. So we had, I don't know, like 8 or 10 fields in this schema. I don't have to manually type all those out. It's going to parse those for me, and the only one that I have to specify is what field is serving as the key, because we want to keep track of the latest value per key, right? So once I write this query, I can execute it within the Confluent Cloud console, and it's going to start bringing in the data from this topic into this table. For the readings data, every reading message is relevant in this ongoing series of events, right? We could potentially trigger the processing off of each of those events. And so we're going to create a stream. It's going to feel very familiar to the create table statement we just saw. And again, we're going to point to the Kafka topic, specify the value format, and it's going to parse those fields and types. I'm going to specify the ID field just for consistency. And now, okay, those inputs are there. Let's actually enrich these two data sets with one another, because we need both of them to actually make sense of the readings, right? So this is a wall of text, just doing the select statement. First, I'm going to extract all the fields that I actually want as output, and we're going to do an inner join just to make sure we have all of the data that we need for this stage of the processing. And so if I took this select statement and executed it as is, this is something called a push query, all right? Executing this is going, ksqlDB is going to push the result set, conduct this join, and push the result set to me as output, and then stop. Everything that's in the topic, it's going to do the join and stop, which, Okay. And it's just going to be output. That's not really useful. So I want to persist this data somewhere. And so I'm going to attach this to a create stream statement. And so we're going to give this output a name, the enriched houseplant readings. I'm going to say which topic I want to store it in. And of course, we're going to have that avro value format. So if I execute this, great. It's going to run that join on everything that's currently in the topic and persist it to that stream. Cool. But it still stops. And so no new data is actually going to be, we're not going to do the join on any new events. And so to do that, I have to add emit changes to the end. And so now when I run this whole thing, it is now a this is a push query. The other one's a pull query. This is a push query, and so everything is going to be pushed to me as output. Every time a new event comes through on the topic, we're going to do this join, execute it, and put it into this stream for us to use. So now I have all the data I need, and we need to start making sense of this information. So the overall goal here is that when my plant has enough low moisture readings indicating that it needs to be watered, I want to receive an alert on my phone. I'm collecting this information every 30 seconds, though. If a plant needs to be watered, I do not want an alert every 30 seconds. That's just ridiculous. And before you ask, I'm collecting this data at that interval just so that I have historic information on my plants, because I am ridiculous and I really do like my plants. So just have it. And so I don't want to receive an alert every 30 seconds. So, okay, maybe once every 6 hours, that's good, right? If I'm out at the office, if I'm traveling or something, that gives me enough time to either get home and do something with that plant, or tell my partner to go water that plant, right? And these sensors aren't perfect. They're $1, right? They could have been nicer. And so I can get false low or high readings, but the general trend over time is that, yeah, the moisture level decreases. That makes sense. So within a given 6-hour period, it's probably good enough with these okay sensors if I receive 1 hour's worth of low readings, right? So if you do the math there, if I'm receiving alerts, messages every 30 seconds, within a 6-hour period, I want to receive at least 120 low readings within that period before I decide to send an alert, okay? So this is the query that I wrote to achieve this, all right? A few key details to focus in on. The first thing I'm going to do is I'm going to set up this query to window, not aggregate the data over non-overlapping 6-hour windows, okay? So when an event flows in, we're going to bucket it into the appropriate window. Within that window, I want to count per plant ID, per window, whether that moisture reading was lower than the low moisture threshold. If it is, we're going to update the state associated with this window, with this plant ID, increment that, and if we get at least 120 readings, great. We are going to output a result. So a couple things to note here, because I think it's pretty important. It's easy when you look at SQL to forget that you're building a streaming application. So every time, when we're windowing and we're conducting an aggregate, the output's going to be a table, right? Because within a particular window, we're going to have multiple, if multiple events flow in, we're going to have multiple potential results, right? So we want to keep track of what the most recent value is and have that output. So as an event flows in, okay, we're first going to bucket it into the appropriate window and group it by plant ID. And then if it meets that threshold, if that moisture threshold is lower than the low moisture threshold that we have, we are going to access that state and increment that counter, right? And if we hit 120, cool, we can output something. But you might be asking, rightfully so, what happens after you hit 120 readings? Are we going to output every 30 seconds then? Because it looks like we will. But we're going to add a little bit at the end here, emit final. So before we used emit changes, emit final is sort of the counterpart. Emit final says wait until this window closes before you output anything. Then assess the threshold, in this case, count above 120 and output if necessary. All right, so this does what we needed to do. Cool. And so that data is in our houseplant low readings topic, ready for me to do something with it. Okay? So we just got to get this information out of Kafka. So how do we do this? Well, Kafka Connect. Okay. So with our Telegram bot, we were given an API key, and with that, I can see at a high level what conversations are happening with my bot. It's only me talking with it, so I have a conversation ID that I can uniquely identify my conversation with that bot. Using that API key and the conversation ID, I can build up an endpoint that I can send information to and receive it on my phone. So conveniently, there's a Kafka Connect HTTP sync connector that is fully managed on Confluent Cloud. I don't have to touch anything. And for its configurations, it just needs to know which endpoint we're going to send data to and which Kafka topic it wants to pull data from. Right? I'm going to add in a little bit of regex there to extract the field that I actually want to send to the conversation. And once this is started up, it's going to see all the messages in that topic. Every time one flows through, it's going to extract that data and push it to my phone with an alert like this. Right? Just to guilt me a little bit. So I'm pretty proud of this pipeline. It's a little ridiculous, but it solves a real problem that I have. It's an ongoing thing. But what do you get out of this? You sat through this. Hopefully you had a little bit of fun of the absurdity of it. But you learned a bit. You did, I promise. You saw some of the ways that you can get data into Kafka using the Producer API or Kafka Connect. You were introduced to stream processing if you haven't really thought about it before with Kafka, how to do this within the Kafka ecosystem with the Consumer Producer API, Kafka Streams, and especially ksqlDB. And then you saw how you can get data out of Kafka, using Kafka Connect toward the end, and how to use the Consumer API to make a script a little more event-driven. So every streaming data pipeline you're going to build from here on out with Kafka is going to use some combination of those three things. Prove me wrong, I dare you. And so now, the next time you think about it, you at least have the tools, the awareness, and hopefully you can hit the ground running. And I hope you will. Have you considered bringing Kafka into your own home? You should. It's really fun. So regardless of where you are on learning Kafka or any of these tools, I have a lot of resources here on my link tree. I have the source code linked to for this project if you want to take a look at it and if you're really inspired and want to do it at home. And then I also have a link to Confluent Developer, which is our portal with a ton of courses ranging from introductory stuff to more advanced things. So I hope you'll check it out. And I know I'm at time. I will be up at table 2, I believe. So if you have any questions, if you want any stickers, if you want any Kafka socks, I have all of those things today, and I'm happy to hand those over. So thank you so much. I appreciate it.
Thank you, Danica.